Greetings, class. This is Mr. D, and we are going to calculate some molarity of an acid. An earlier video that we did, we calculated the volume of base needed to cancel out some acid. The acid that we had used at that time was supposed to be about 40 milliliters. And if you see the other ones, you just have to be close. You don't have to be super close to it, but make sure you write down whatever it is because you will use that for the math. Now, when it came to this one, my test, I used 44.2 milliliters. 44.2 milliliters. That's close enough to 40. I'm going to just accept that as it is. Now, in order to do this math, I need to know how much volume of base I needed to cancel out my 44.2 milliliters of acid, which I had in a beaker below my burette off screen where you could not see it. So it was not on the camera, but it was there. So what I had to do in my last video, I calculated how much volume of base I needed to cancel this acid. Now the base was a given molarity of 0.5 molar, and I needed 21.21 milliliters in order to do that. Now I need to do this math in order to get my molarity of my acid, since that was what I was looking for. When I did this, I was like, okay, well, what do I have to start with? Since I want this molarity of the acid, I need to use what I have from the base to get the moles of my acid, and then I will use the milliliters of my acid to get the molarity. Stay tuned, here we go. So I started with 21.21 milliliters of my base. I need to change that to liters. So milliliters to liters, 1,000 milliliters per liter. Now that it is in liters, I can use this molarity that was given to me. So this molarity of base that was given to me was, for every 1 liter of base, I had 0.50 moles of base. That's good. Then I can use my stoichiometry to go from my base to my acid. Now this is a 1-to-1 ratio, so for every 1 moles of base, I have 1 moles of acids. This was actually pretty easy, but it's still important that I do that. This is half of what I need to get the molarity of acid. The other thing I need is I need this volume of acid that I calculated earlier. See, I know that it is 44.2 milliliters of my acid, but I need to convert that using metric, just like I did before. So I'm going to times line milliliter down, liter up, 1 liter to 1,000 milliliters. In my class, I call this a two-string problem. I have my one string, my other string, and we're going to get a nice thread for our answer. So when I do this, my temporary solution so far will be 0.0442 liters of my acid. And over here for my moles, well, I need to calculate that out. And I will get 21.21 divided by 1,000 times 0.5, and then times 1 divided by 1 I really don't need to worry about. But the moles I get are 0.010605. Now I don't want to shorten any of this yet. I will be doing that in just a moment. So what I now need to do is I need to take my moles, I need to divide it by my liters, and that will give me an answer that I will want, because that will then be moles per liter, which is very important. So I take that number I just calculated, divide it by 0.0442 that I had gotten earlier, and I get a raw answer, so an answer that is not yet modified, of 0.2399. And there's more, but I don't care, because I need to turn this into 2 sig digs. Why? I have 2 sig digs, 4 sig digs, 3 sig digs. I got to go with the lowest one. This 0 is a placeholder, so these two are significant. The 9 will round it up, which gives me my final answer which will be 0.24 moles per liters or molar. So over here, I got 0.24 molar. This is going to be important for what I do later. Now that I have these three molarities, I need to get the average of them so I can find out my percent error so I can see if I did this lab properly. So stick around because here we go. Now we're going to calculate our average. To calculate our average, we're going to get a few of the things we had earlier. Our molarities from our two tests plus our new molarity, which was 0.24 that we calculated in the last slide. We're going to add them all together and divide by 3 because we have three different numbers that we are adding, hence the divide by 3 to get our average of 0.26 molar. So that was our average. We then need to fill in the percent error formula that you see above. The accepted values are what we were looking for. We were looking for 0.25 molar. That's what we wanted. That was what we had accepted to be true and what we had hoped to be true. But when we measured, we didn't quite get that. We got something slightly off. That's okay. We can now do the math that is above to get our error statement, which is just 4.0%. Again, two significant digits. The conclusion is this is good. We're less than 10% error, considering this was a high school lab done. Many of the people who did this were doing this for the first time. This is how you calculate molarity, average, and percent error. Good luck in your labs. Take care.